Hi everyone, and welcome to our fourth video cast of the Sensation and Perception unit. This video cast is actually part 1 and part 2. So number 4 and 5 are both in the same topic. They're on the topic of perception, but I split it up just because there's a lot of information. So really the question is, what is the relationship between sensation and perception? Like, how do they relate, right? So perception is what brings meaning to the sensations. Sensations go in, and perception is what gives it meaning. It organizes it. It gives you some sort of interpretation of the world outside of you, right? And it's not a perfect representation of it. It's just an interpretation of it. That's why sometimes, you've ever seen like visual illusions or whatever. That's how visual illusions actually work. It's because what they do is they use the way that your brain is supposed to think about the world and kind of tricks your brain. So we've already talked about this a little bit before in the very first one, but I just want to go over it again because it's very important to understand, right? When you talk about sensation, you're using bottom-up processing. This is when your analysis of your world looks at all of the features rather than the internal concept. So, for example, if you were trying to look at a flower in the field, you would look at the color and the shape and the nose sends the smell to your brain, not the sound, right? And so then all of those little things then go up to your brain, and your brain says, oh, that's a flower, right? Or, oh, I'm in a field of flowers, right? So you look at all the little individual parts, and it starts from the bottom and then gets processed up in the brain. This is very different than top down. Top down is when you use your expectations, your memories, your knowledge, your cultural background, or other things to actually understand the world around you. So a great example of this is this, right? A lot of you might have looked at it and thought, what in the world did Ms. Schaefer put on the PowerPoint? Actually, these are feet. That's right, these are feet. This is one heel, this is another heel, right? But top-down processing, you have the expectation and the memories and the prior knowledge that this kind of looks like, a butt, right? So this is top-down, where your eyes did not tell your brain what this was. Your brain told your eyes that it was a woman who was dressed inappropriately, but really it's just feet. Okay, here's another example of this, right? Even though the second letter in each of the words is ambiguous, so this letter is the same as this letter, top-down processing allows for you to read it as the cat. Because you know T and H, this is the, and C and A, or C and T, this must be an A. So even though it's ambiguous, right, you're able to read it as the cat, and you see this is an H and this is an A, and that's because top-down processing, your brain is telling your eyes what to expect. You know that you've seen these words before. Okay, so how is your perception organized, right? So one of the most important things that I mentioned this before is visual capture. And this is the idea that your vision dominates all the other senses. Okay? And most of the time, the way that we understand the world around us is we use something called the Gestalt principle. This is the idea that instead of humans seeing all the individual little parts of the world around them, they actually see the world in whole, and they look for patterns and things, okay? An example is that you see a square, not 4 straight lines, and you see a school of fish, right? Not one independent fish, and you hear a melody, not like each random note, okay? So you tend to see things as a whole, and you make patterns as opposed to the individual parts. There's 2 basic ways to do this: figure, ground, and grouping. So figure ground, right, is that the idea that your mind decides what's the figure, what are you focusing on, and what's the background. So in this idea, if you focus on the black as the figure, you see men running down the stairs, and the white is the background. But if the white becomes the figure, you see arrows going up, right, and arrows going down, and then the black is the background. Same thing here. What's the figure and what's the background, okay? Obviously, you could see a boat, right, and trees, or how many of you realize that this is actually a face, right? So if you focus on the black as the figure, you kind of see the boat and whatever, and if you focus on the blue as the figure, then you kind of see the face. This is the mouth and the nose. Another example of this is FedEx. Look, okay, there's an arrow here, right? So if you focus on the white, this is a figure, then the X becomes the background. So here's the different laws of grouping you have to know: similarity, proximity, continuity, connectedness, and closure. They're actually pretty easy to understand once you see them. So proximity is the idea that we group figures together that are closer together. So you see this as 3 groups of 2, not 6, right? Because these 2 are closest and these 2 are closest and these 2. So this is 3 groups of 2 lines. Similarity is that we tend to group together objects that look similar. So you see this as triangles, circles, triangles, right? Continuity is the idea that you like to see things as continuing, right? So we don't see this as stop, 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 right? We see it as okay? And connectedness is the idea that you see this is a whole, and this is a whole, and this is a whole, right? These are each individual pieces. An example of this in your real life is that when you walk through the cafeteria, you see lots of different people seated at different tables, right? You perceive those individuals that are near to each other as friends. This is the law of proximity. So people who sit closer together than others, you group them together, and that grouping of people who are closest is proximity. Another grouping principle is called closure, right? So how many of you take a look at this can actually see the triangle here, right? It's pretty cool, okay? There's not actually a triangle there, okay? But it looks like a big white triangle is popping out at you. That's the idea of closure. Your mind closes in the gaps and makes a triangle. Sorry, those didn't really work out well, but I'll show you more in class. So this is an example of closure because this is not actually a box, right? There is no lines here. It's actually circles with little cutouts, but you see it as a square, okay? This is an example of continuity, right? Because you see it as a line continuing, right? This is an example of closure because you're able to connect the dots and make the face. This is an example of proximity because you see this as a group and this as a group, and these are closest together, and there's like a space here, so you're able to see it as a U, right? These things are seen as closer together, so you tend to group them together, okay? And this is an example of similarity. So you see it as an X and then a bunch of dots. The things that are similar to each other, you group together. The boxes you group together to make an X. The circles you group together to make squares. All right, what about depth perception? How do you organize the world in 3D, right? So depth perception is your ability to judge objects in 3 dimensions or to judge distance. And what they found is that they actually used this experiment called the visual cliff to know that we're actually born with depth perception. So Gibson and Walk found that all species tested can perceive and avoid a sharp drop by the time they take up independent motion. So if you look at this, right, they like put a mirror here and it looks like a cliff, but it's not actually a cliff. And they found that at the point where babies are moving around and crawling, that they will like no longer, like they will like hesitate because they will see that this could drop off and they're nervous and afraid and they won't go onto it even though it's a mirror, okay? I'll show you a video of this in class that makes it a little clearer. But this is called the visual cliff experiment, and it proves that we're all kind of born with depth perception. Okay, so there's 2 different ways that your eyes can see depth: binocular and monocular. Binocular depth cues is information that needs both eyes. Binocular, both eyes, right? So one binocular cue is retinal disparity. This is the idea that your eyes see slightly different images, and so this is what allows you to see it in 3D, okay? The other one is something called binocular convergence, right? And this is the idea that your eyes actually like rotate and converge to focus on an object. And, you know, when you look at an object that's closer than 25 feet, your eyes actually have to converge on the object or rotate in order for you to see it in focus, okay? Binocular cues are the best for depth. You need both eyes to see depth the best that you can see it, okay? But it is possible for you to see depth with one eye, right? And then a good example of this is when you look at pictures, like posters or pictures online or whatever. Those are actually 2D, but you're able to see 3D. So here's the monocular depth cues you have to know. The first one is relative size. So this is the idea that the smaller image of 2 actually appears more distant. Interposition. When one object is blocking the other object, the one that's blocking it looks closer. Clarity. So hazy objects are seen as more distant. Texture. So the closer the object is to you, the coarser it looks. The further away, the smoother it looks. Height. Higher objects in a picture are seen as farther away. Relative motion. And I'll show you something in class, a little like video that shows this to you. But the closer something is to you, it looks like it's moving the opposite direction. And the farther something is away from you, it looks like it's moving in the same direction. Linear perspective. So this is the idea that like parallel lines look like they converge in the distance at the horizon. Okay? And light and shadow, dimmer objects seem more distant. So here's an example of this, right? So you see here, right, that these guys, this is interposition. So he is blocking him, so we know he's closer, okay? This is much more coarse. This is much more like fine. You know, you don't really see it. It's smooth, right? This is the texture gradient, okay? An example of height is that, you know, these guys are relative size. So these guys are obviously seen as behind these guys because they're smaller, okay? If you look at the relative clarity, right, this is much less clear than this is up in the front, right? So this is how you understand and see the world around you as 3D. Another example, this is relative height. So these things look higher in the picture than these things. So these things look farther back, right? This is the linear perspective. So parallel lines tend to converge at the horizon, okay? This is relative clarity, very clear here, kind of hazy in the background. You know, these guys are seen as closer to you than these guys because they're bigger, relative size. So those are all examples, right, of the different perceptual monocular depth cues, okay? All right, that's all for now, AP Psychos. And remember, psychology is flippin' awesome.